Okay, so welcome to the Rust Maven meetup or meeting or whatever we have. This is we are uploading it to the Code Maven channel on YouTube, this video that contains various other types of videos as well. So it's Rust, Python, some Perl. So welcome to the meeting. I'm really happy that there are like 15, we are like 15 people here. And welcome to people who are watching the video. My name is Gabor. I usually teach Rust and teach Python and some version control and test automation and help companies introduce test automation. And recently I started this. I used to record videos and do these live sessions, but I thought it was much better to invite guests who know way more things than I do and let them explain things and even teach me things. So I found Mark, and I was really happy that I can learn some WebAssembly from him. So Mark, welcome. Please, actually, I think I'm sharing the screen instead of talking into the camera. So I'm going to stop the share, and hopefully you can see me now. So hi, and now it's your turn, Mark. Please introduce yourself, and then we go from there.
Yeah, sure. Thank you. I don't know if I need to talk much about myself, but just in a couple of sentences, I actually am working with multiple technologies. Rust is one of them, albeit not recently, unfortunately. But previous to my current engagements, I spent a lot of time figuring out how WebAssembly can be used in the browser in sort of an efficient way or in terms of development experience. I started to work on a crate which helped creating source maps for WebAssemblies, which is not something currently present in the Rust WebAssembly ecosystem. And since then, I worked on many other tooling projects with Rust. Right now, thanks to you, I'm here to introduce everybody to basically WebAssembly and do it with Rust and see how exactly we can take it to a level where you can actually get started building real applications and real solutions with Rust in WebAssembly.
Nice. Okay. I don't know much about WebAssembly, so some little
Sure.
theory of it. I just wanted to say also that, yeah, so let's actually share the screen and then just making sure that I'm sharing the right screen. Hopefully you're seeing your article, right? So I'm putting
Yes.
this in the chat for anyone who
Thank
would
you.
like to take a look at the article. Mark sent it to me a couple of days ago, and obviously I postponed everything and I started to go read it only just today. He asked me to do some installations before we get to the video. So you might also need to do some of the things if you'd like to follow this, or later on you would like to implement the same things. So what I have is I installed all this stuff, including setting up. Let me enlarge the font a little bit, including setting up this repository, this WASM on web, and I opened Visual Studio Code on that in that project, and I even opened the file because I couldn't figure out why I don't see it large enough. But anyway, we are here, and that's it.
Yeah.
So I have no idea
So
what I did. I just followed your instructions.
cool. I'm going to walk you through. But before we do that, let's just spend a couple of minutes and talk about what exactly is the significance of WebAssembly. Why exactly WebAssembly, the new kid on the block, is the solution proposed by many companies and nonprofits, and that will lead us to our example project, which you just opened and everybody can see. So first of all, WebAssembly, the promise of WebAssembly is basically a runtime which is platform independent. That means it's not like a program you use like an exe, a Windows program, which you can only run on Windows and x86. But you have to have a separate binary which can only run on Mac OS and a separate third binary to run on Linux, etc., etc. So this is basically WebAssembly's promise. You would have just one compiled binary. It can run anywhere. And obviously, if you're experienced with the history of software development, you know that this is not the first time this is attempted. One notable example, probably the older ones in the audience will remember, is Java, the Java virtual machine, which promised the same thing. Unfortunately, it was probably too soon. And even though Java is very prominent in some of the areas and sectors in IT, like banks and other solutions, it really is not relevant anymore for us. The other one significant and notable before WebAssembly was .NET, Microsoft's .NET. It's still sort of actively maintained and actively basically cared for by Microsoft. They basically built their full platform on .NET, and it will not go away, but it's still limited. So basically, mostly Windows, even if you can run it on Unix operating systems easily, people don't tend to use it. It's a very closed space. So
Right.
and honestly, one of the aspects of .NET which hurts .NET pretty much, in my opinion, is that they don't really have a web runtime, so they can't run .NET applications in web and support many use cases. So that limits their potential use cases. So this is where WebAssembly fits into the whole idea. In 2017, a couple of companies and nonprofits came together and figured they might need to do something, but it has to be open, not in not in terms of open source exclusively, but what I mean is openly specified and openly
Yeah.
maintained by a consortium. So that's WebAssembly. And honestly, it seems that it worked for the World Wide Web, and it's probably going to work for WebAssembly. But I want to point out that WebAssembly is still very young in its life cycle, and it has a lot of problems, even though you'll see today that you can get started in Rust, and by the way, you can probably do the same thing in C, C++, and get great results. But we will also talk about some of the nitpicky, problematic things which you might run into early in your WebAssembly career, and hopefully how to solve it. So it's not the best developer experience, but it's usable, which is good enough for us most of the time. So what exactly is WebAssembly other than a free and open standard? It's basically an instruction set. An ISA, basically, it's a 32-bit instruction
Wait a
set.
second, just a second. I have a question actually to the
Sure, go
audience.
ahead.
Please, and I hopefully you know how to raise your hand in not like personally, but in Zoom. So please raise your hand if you have ever written any code in assembly, in any assembler. Okay, there is one. I mean, I wrote like 40 years ago assembler manually. And I call two people, three people. Okay, so there are a few people who wrote assembler. That's nice.
Oh, wow. Okay.
Okay,
Those are long forgotten memories for me, but yeah, I'm old enough to remember and even use some assembly. But yeah, it's actually not an unexpected comparison, because WebAssembly is indeed sort of that level of complexity as assembly was for the native platforms. It actually is the same as ISA, basically an instruction set architecture. It's just in a virtual machine, basically, you would say. So it's
right.
basically a virtual machine, but it's I'm hesitant to call it a virtual machine because it lacks a lot of functionalities people usually associate with virtual machines. Like there is no garbage collection, anything high level. It really is very comparable to what you would expect from a very simple assembly powered architecture and instruction set. Basically, just what you would use. Obviously, the simplification can be powerful in terms of like execution speed and performance, even though, again, as I mentioned, it runs in an isolated virtual machine, so the speed will never compare really ever in the future. It won't be able to compare to like runtimes on the native platforms or like native binaries, but that's not the point. The point is accessibility, as that it runs on web primarily, but you can use it basically as a virtual machine and run WebAssembly code on your desktop as well, even though that's very much in the early phases. Basically, it works. It can do system calls, whatever, basically AC or assembly code translated to binary or compared to binary could do. We will see that at the end of the
Okay.
event today. So, okay, I don't want to spend more time on the details. If you're interested in some more coherent introduction into what exactly WebAssembly is, the article is a great place to start. I'll try to explain everything you will need if you want to understand what WebAssembly is. But today, we only need to understand how to use the tools at our disposal to build something on WebAssembly. So, as Gabor mentioned, the first step is setting up the tooling. You will need the JavaScript, Node.js tool space, and the Rust tool space. We are going to actually build a project with Node.js and browser-based code, JavaScript, TypeScript, and Rust at the same directory, same source root, just to demonstrate that Rust and basically WebAssembly and JavaScript, TypeScript can coexist inside a single project if that's what you want. You don't have to separate them. Okay, so the key part here, as Gabor mentioned, is that I'm going to use Yarn, the package manager for JavaScript, to demonstrate this project or demonstrate the end goal. And in this case, I use Vite, which is a popular framework, just because it's easier to set up, just to save on time. You don't have to use Vite. You can use any other framework if you have
how do you spell the name? Sorry.
Vite.
Like
Vite, Vite.
Bite?
Yes.
Okay. Like, okay.
It's the framework which I prefer to demonstrate with because it's easy and very robust. Has a lot of plugins, which we will see we will need. And
so if I search for it, I say Byte framework.
no, not B, V, like vector. Yep.
Okay.
It's Vite Dev, most likely.
Okay.
Yep, that's the one. So that yarn command you've shown in the article and with what we discussed is basically just a quick one-liner to create a project folder, download a template with TypeScript, because we're going to use TypeScript. Most serious people, I think, use TypeScript nowadays. It will be named WASM on web. You can change it to whatever you want. We just today call it WASM on web. And the rest of it is basically just setting up Git, because we will need Git in a moment. Setting up Rust. We're going to use stable Rust. Can you scroll a little bit further down?
Yeah, so here just as much as I remember, here there's the setup of the Git repository, and then there are instructions to set up Rust. I already had Rust on my system, so I didn't have to. Number of cargo installs. I run this.
Yeah, but the key part here is that we are going to cross-compile. Your machine doesn't run on WebAssembly. You have to
Right.
cross-compile your Rust code into WebAssembly. So first of all, this is the key part Gabor highlighted. You have to add this target, WASM32 unknown to your target list on Rust app. So it downloads the standard library for the Rust ecosystem. So you can compile basically what you would expect for Rust, like string, basically the what's it called? The annotations, macros you would expect basically compiled down to WASM32, so it will be ready for you. Yes, there are a couple of tools. These are optional. I'll put it in the article because we will use some of these tools just to show you what's in the inside of whatever artifacts we build. You don't have to use them if you don't want to. The only exception is WASM pack, the last one. In cargo install WASM pack. We're going to use WASM pack because it's a custom builder. It uses cargo in the back. In the backend, but makes your life with WebAssembly and Rust way, way easier. It wouldn't be possible to write this article without WASM-Pack. Although it would have been more educational, but I want to get you through most of this in 45 minutes. So the rest, oh, there is one more thing, which is cargo generates. I just want to point it out. That's going to be, we're going to use cargo generate to just download the template for Rust, the Rust part of the project, which I will ask Gabor to do right now. So
So I should
can
run
you,
this one.
yes, but you have to step one directory out because you see the name WASM on web is going to be a directory. So you need to overlay basically the Rust template on the byte template.
Right, I have to be inside the WASM
No,
on web.
never mind. Yes, you're right. You're right. I forgot. Yes. So you have to be inside, hopefully.
Yeah,
Hopefully you have Git.
So here, this is the folder I already set up. I think I already ran the previous command, so the one that we
Yes.
had here, the yarn install, and now I just paste this one.
Hopefully it will work.
There is some green thing there. Oh, that's just from the Zoom.
Perfect. So if you open up,
this just let me show you. This one is something from Zoom. I have no idea what is that.
me neither. So if you
Okay.
open up WS Code, not VS Code, hopefully you will see in the directory structure if you open up the Explorer.
Well, I like.
Yep.
Wait a second. What if I run 3?
Well, I don't know if it's helpful.
Way too much stuff here. Not useful. Okay.
Yeah, most of these are just dependencies for TypeScript and Vite. So it's probably easier if you show it in VS Code. So what happened here with the overlaying of the Rust project? First of all, we have a lib.rs and the utils.rs. These are going to be our Rust source codes. Again, at this point, why not main.rs? You would expect. You would ask. Due to how WebAssembly works, you can only build libraries for WebAssembly. You cannot build like self-containing, self-running applications. It has to be a library project every time.
Okay.
Therefore, we have lib.rs here. And we got a goodie we're going to talk about in the utils rs, which is not necessary at all, but it sets a panic handler, which is not present by default on WebAssembly and in this setup. But the whole, you will see the package soon, the binding generation code and WASM pack brings this addition, a nice addition, which would let us actually see on the console error, so the browser console, if the Rust code panics. Otherwise, you wouldn't see anything. It just doesn't work. So I highly recommend setting up this panic hook, but it is done for us here. If you open up lib.rs, you will see how exactly it happens, I think. Yeah, so if you see the part, like that it is defined as a mod util, so it's just a module. It basically will be picked up automatically because of the naming, because of the name of the function in utils.rs. So as long as you have this function present in your code and it's not nested in anything else, it will be picked up as the panic handler automatically and will be used. Okay, so what else? Yes, so we have the cargo toml file, which actually contains the key tool. Can you open the cargo toml? Yes, thank you. So contains the key dependency which we will need. It's called on line 14 WASM bingen. This is where the magic happens basically. This is a binding generator. If you're familiar with C, maybe Rust, basically foreign function call interfaces usually generated with these bind generators. WASM has a very similar sort of interface, which is foreign to Rust. This is where the WASM binding package comes in. It automatically generates these bindings for us. And later down the road, we will see that there are additional packages which are sort of like in the Rust ecosystem, they are called sys packages. You will see that there is a web sys package, which contains all the goodies for all the JavaScript browser built-in functions as well. So you can even call JavaScript functions, sort of browser-based JavaScript functions with ease from Rust. We'll see it very soon. And the rest is not really.
There's a comment from Gregory that you can do binaries in WASM 32, but usually for non-standard environments like IoT or blockchains. And WASM bingen is specifically for a lib binding to a TypeScript interface that loads this lib.
Yes, we are talking about browsers in this context, specifically in the first half. Hopefully we will have time. I will mention that there are currently options to run it outside of the browser through what's called WASI, but that's not really a well-developed interface. So let's focus on the browsers first, because that's something which we can use today and get quick results. But thanks for the comment. Okay, what's next? I think we should get started and just hopefully build our project. So first of all, can you try to run wasm back in the console, wasm back build and dash dev? Can you try that, please?
Sorry,
in the console, yes. Just wasm back, dash back, not backpack, wasm back, like packaging, yes. Build. Yes, like dash dev. So it's cargo build, but it's wasm back build in this case, and in dev mode, just run it. And in the explore section, hopefully, you will see that it will create for us a ready-made JavaScript npm.js ready package, which is important. Okay, so can you show us the file structure? It's in a new directory. It should be in a new directory. It's called pkg. Probably you need to scroll up.
Okay.
Yep, we have a pkg directory. So this is a self-contained npm.js package. You can even publish it as it is right now. It has a package JSON with the metadata, everything you need to get it running and calling it from any other npm.js package or JavaScript or TypeScript packages. One other thing I would like to point out, and this is why I wanted to use TypeScript, is that you have type definitions, and you will see that we will automatically generate TypeScript type definitions for our Rust types that we export. That's the wasm_web _bg.wasm.d.ts. That's basically a type definition for TypeScript. It will automatically be picked up, and hopefully will be easy for you to use and figure out what kind of types are exported.
Sorry, wait a second. I'll try to, I just put here notes, at least the comments.
Okay, so
Okay.
that's great. Now we would need to use this WASM package, because if you take a look at lib.rs, hopefully you'll see that there's already a greet function exported for us.
Yeah, here.
So we can actually get started right now. Can you open up main.ts? Just that's the file name, main.ts.
Oops, wrong something. Main TS. Okay.
Yes, this is our entry point for the TypeScript part of the application. Just to verify that everything works in the console, you can run yarn space dev. This will only do what it does for the TypeScript part. We are not yet wired Rust and the TypeScript part together. So if you take a look at the localhost URL it posted here, it should
And I think
load
you
the
said
base.
that I need Chrome for this.
Yes.
Oh, it's so small.
Yeah,
This
but
one is a,
specifically
hopefully
it's
this
going to
is
be
the copy.
specifically you'll need it for a later step, but Chrome is fine for now, or any other browser. We will actually.
Well, okay, I'll just open it in Chrome.
Perfect. I mean, you can see that it works. So let's hook in the Rust part. So if you go back to VS Code, you will see that in the file structure, you will see that there is a package.json in the root folder. So that's your project metadata. Probably not that one. That's for the Rust WASM package. In the root folder, you will find another package.json. Probably at the bottom, I would guess. Second one, yes. So that's your project metadata. What you need to do is you need to add this WASM package to your root project in order to import it in the main TS. So if you quit, just Ctrl+C on the white console in the terminal. Just quit the white runner. Yes. If you say yarn space add link, and you know what? Can you search it in the article? It's probably easier that way, because I'm worried that we're gonna mistype.
That's why I write articles, because I forget things and I can look it up. I mean,
Yeah, so while you look it up, I'm going to explain why exactly we are using this special link. Just search for link and you will, oh yeah, that's it. So the reason why we're using it this way is that by default, Yarn copies your packages, even if they are local packages, into the dependency library, or the dependency directory, sorry, which is not very useful if we keep updating our code, because it will not update the dependencies. But if we use this linking, it will symlink the package directory. So every time we update our WASM, it will automatically be picked up by our main project. So copy and paste this and add it to your.
wait a second, just a second. Before we go do that, I wanted to check the Git status and see what should we add to Git. Everything what is generated here. The node modules are generated.
Not node modules or the PKG directory, but I see that the PKG directory is not added.
Okay, so this one, node modules.
I think that's enough for us. Yeah,
So
that's
the test
fine.
source, readme, and notes.
I
is
would
my
add everything
notes.
else.
Everything else, look, it is a Travis YAML. Okay.
Yeah, it's an old template, but it works reliably. So
okay. So
Just drop it if you don't want to.
no, it's okay. We will have some history there. There's an up here also. Okay. So I don't know. Step one. I have no idea what to put here comments, but
Perfect.
it's fine. I just wanted to have some record of what we are doing.
Of
Okay.
course.
I go back to this one, and you say to copy paste this command
Yes.
and run
And it
it.
has to be in the root directory. Yes.
Yeah, I
Perfect.
mean, oh, okay.
Yeah. So this is standard. It's always named PKG. It's done. And hopefully it will update the package JSON as well. If not,
Let's
then,
see.
oh,
I'll go
yeah,
out
there it is.
here. It's sort of, so yeah, git diff. We can see this was the change in the package JSON.
Mhm.
It added this dependency, I see.
Yes.
And in the
So,
yarn log file, it also added itself.
yes.
Okay.
So now that we link together our WASM and the main TypeScript project, we can actually just call into the WASM code and see what happens. So in the main TS file, I don't know if you're familiar with JavaScript at all.
Yeah.
Are you somewhat? Okay, so I'm not gonna like spell things out for you. Just import
Oh,
greet.
no, that's familiar. Yeah, okay. So
Well, you
go
see the
ahead.
example
No,
up
it's
top.
import here. Yeah, okay.
So I'll help you because we have the shared session if you need to. But simply just import greet, like setup counter, very similar with the brackets. Import greet in the brackets because it's, yeah, see, that's already actually picks it up from the type definitions. So we already imported greet, and at the bottom of the file, maybe we should just call greet. I don't think it has any parameters, so just call it like a normal JavaScript function.
Just here, I'm calling
Yeah,
it.
just I think it's just greet, and it doesn't have any.
Hmm.
I think
No semicolon here. What?
you don't have to in JavaScript. You can
I
be
know
loosey
you don't
goosey.
have to, but it's like, okay, whatever.
I mean, whatever you prefer, it works for us. So again, that would be it. We just need to do yarn dev in the console, and if all is good, all
That
is
looks good to you?
definitely all is definitely not good. So this is our first milestone where we need to modify things. Problem is, Byte by default doesn't know what a WASM is. We need to add a couple of plugins to Byte in order to pick up and properly hoist the generated WASM and JavaScript glue files into our TypeScript project. So if you go back to the article a little bit, you will find
This one?
yes, you need to add these plugins. One of them is mine, so shameless self-plug. The Wasm Pack Watcher is a plugin I created just for this occasion, which will help you iteratively develop the Rust and the TypeScript code together, because it will watch the Rust code base along with the TypeScript code base. So if you make any modifications and save the Rust files, it will compile reload. Hopefully it will work for
Okay.
us. So we
In the
added
meantime,
these plugins.
there are some questions I see.
Okay.
Shall I read it or yeah? I'll read it out and then you can respond. So it wasn't Bingen is mature specifically for web and Node. May I ask what the WASM plugin and top level await, which is one word,
Okay.
are doing precisely in White? Some code example, and then is top level. I can
Yes.
search
So
for.
top level await, the plugin we just installed is only needed for older white projects, but I added it because who knows if people want to actually integrate this workflow into their older white project. What it did is basically allowed calling async functions without any shenanigans just in the root of a JavaScript file or config file. Yeah, so basically, if you're familiar with how JavaScript works, you can't just call async functions and await them on the root context, on the global context. You have to do some hoops, basically embedding them in another function, which is async, declared async, and then you can await your functions inside that async function, which you can call separately. That actually is a problem for the next plugin, which is the WASM back. No, sorry, it's just a WASM plugin. Yes,
Sorry.
basically, yes. Answering the comment. The other one is the key one, white plugin WASM. That's the key. That's the one which does the hoisting for the white parts. The third one, the white plugin WASM pack watcher, you don't need it. We will use it because it will help us quickly iterate. The key is the first one, white plugin WASM. That's what we're going to use. And let's continue just so we don't run out of time.
Okay.
Can you create the white config dev ts file? You're standing at it right now, the contents. But the
Sorry,
file
this
name is
one, it's
up
called,
top.
this one, white config dev.ts.
Yes.
Wow, that's a long name.
Yes.
And I copied this one, right?
Yes.
White
So we're
config
gonna
dev.ts.
yes, we're gonna create two white config files, even though usually there is only one. The reason being is that I want us to use the plugin, the Watcher plugin I built for development,
Where
which is
should I save
incompatible.
this? Sorry, I have to move it out so I can see the size of the.
Sure.
Which folder should I put it?
It must be in the root folder.
Okay. I had to move it to my other screen because I couldn't see and I can't enlarge those letters there.
Okay, so yes, and then create the other file.
So just a second, I put it here in the root.
Perfect.
Okay.
Create the other file without the .dev part, white config.ts. That's the production build configuration.
White config.ts. So
yes, usually that's the standard white config file, which we will use for production builds. It does not contain my Watcher plugin because if you have my Watcher plugin, your build will never end. It's just an unfortunate artifact of things, but it doesn't matter.
Right. Sorry for this. I had to change. Yeah. Okay, so I have now both of them here, hopefully.
Okay,
These two
so
files.
then hopefully we can actually start working with our code. Just to speed things up, if you take a look at my article, just immediately below what you copied, you will see a section called yarn add npm run all. Yes, let's run this just quickly. Let's just copy paste. I'm gonna explain what's gonna happen. This is just a helper, Node.js helper to help us run commands in a sequential parallel fashion. And it works platform agnostically. So if you're on Windows, it will work for you too. I just wanted to make sure that I respect people who actually work on different non-Unix systems. And then if you go back to my article, you will see a section scripts. Just copy the inside and put it in package.json. I wrote it for you guys. You can just copy paste. Yes, just replace the old script section in the package.json in the root.
This one.
Yes.
And I have this
scripts,
one I replaced.
And just replace that. Yeah. I created this step-by-step script sections so it will work on all platforms. It's easy to follow what's going on, and it will help us make things easier. So I believe we are ready. Just do yarn dev, and if we actually did everything all right, then
wow.
Oh, perfect. Okay, so you can see that it compiled the Rust code into WASM and then started yarn, and we already see the alert from the Rust WASM code. So this is our first milestone. We are called into the WASM code on web. It displayed an alert and returned to JavaScript, and the JavaScript just went on running.
Okay.
Going forward,
Wait a second.
please open up.
Just 1 second. So I have this greet function that is the
Yes.
pop-up, and
No, that is a function you call from the Rust code. If you open the lib.rs, you will see that that is our exported function.
right. Yeah. Okay. So the greet is coming from Rust, and then it calls the alert,
Yes.
right?
So,
And
okay.
the website only shows after everything is executed here, right?
Yes,
So
because it runs an runs an alert which stops the rendering of the code. It's not because you
Okay.
code into Rust. It's just a quirk of
Right.
how rendering works.
Right. There's a
So we'll,
sub-question. So, and the WASM plugin, what, sorry? Okay, so top level, await or,
no, that was a follow-up question when I explained that the WASM plugin is the key of all the
oh,
hoisting part. So hopefully that is answered.
okay,
If not, then just ask again, and
good.
we're gonna come back and talk about it. So right now we are at the milestone where you probably would like to have a Git commit because it's
Definitely.
working.
I do way more Git commits
Cool.
than,
We have everything set up for development, and the good news is, if you change anything in the Rust code or the TypeScript code, it will reload in your browser. For those of you coming from the JavaScript side, this is not hot reloads. And I know Vite supports hot reload, but you can't do it with Rust. If you modify the Rust code, it has to reload the whole application. That's just the way it is. It's actually, you don't have to use the Watcher plugin, but I think it makes easier iterating on the code when you work in this dual setup where you have WASM and TypeScript in the same project. Up to you. That's what we're gonna do because it's easier for us for this presentation. You do you, I guess. So
yeah. By the way,
I
right
think
now, the repository is just local to me. I'm going to create a Git, something, I will put it on
sure.
GitHub, so you will have this, and we'll put the link below the video or somewhere for the repository.
Okay. So let's talk about how exactly can a Rust implementation of a function can call into the browser function alert. If you go back to librs, we'll see the glue code part, which is the extern C block. I don't know how many of you used FFI, sorry, with Rust. These extern C blocks, basically, for those of you who didn't before, these extern C blocks say that there are external functions which you will call in your Rust code. Don't worry about it, Rust compiler. Everything's all right. I know what I'm doing. And even your IDE shows that it is unsafe, even though you no longer need to mark that unsafe. It is unsafe. You have to guarantee that the signature of the functions you put here are actually correct. Otherwise, it will panic. So again, you see the heritage of WebAssembly, the C type of external function definitions, it follows the C conventions for function calling. It's the exact same as you would call into a library built by a C linker. That's why it's an external block with C calling conventions. And right now, alert is super simple. If you see the JavaScript part, it's basically alert, single string parameter. It shows you the alert box. Same here in the extend part. It's an alert, and it actually receives a string slice, a view into an own string. And basically, it's just the WASM bin and macro added on top of it, just takes care of everything, wires it up for you, and does the calling into the JavaScript browser engine. And as you can see, and you saw previously, it just works. So this is actually the easy example. I don't know how much time we have. The next section would be if we could do some more complicated type of callings, like calling
I
from.
okay. Sorry, just finish the sentence. Sorry.
Yeah, so the next section is basically going to show us how to call our functions, JavaScript functions from Rust. Shall we
So
proceed?
I think maybe we should have like 5 minutes break. I stop the recording for now, and then we'll put it in probably in a separate video. What do you think?
Sure.
Do you think it's good?
Sure.
People,
That's
I mean,
good.
for you as well. I mean, you have been talking for almost an hour now.
I'm happy to continue. The best part's the next part is the best part, I think.
I'm sure, but okay. So we don't have to have a break. Okay, that's fine. Okay, that's good also.
All
So go
right.
ahead then.
So let's proceed then. So let's create a function in main TS in a very specific way. If you go back to main.ts,
Just a second. I'll close all the other things
sure.
that we don't need.
Yeah, we won't need them. You can actually do a split screen if you want with the lib.rs and main.ts, and then
Okay, just tell me how because I never do that.
yeah, okay. So you have to like
This one.
grab that works too, but yeah, I usually just grab the tab and works too. Perfect.
How do you do that? You take it and grab it like
Yeah,
this?
grab it to the side, to all the way to the side and just to the middle, side and the middle.
Oh,
Almost, almost.
no, didn't like it? No, okay.
There you
Good.
go.
Learning how to use the editor. Okay.
Cool. All right, so we can actually see both of them, and it's probably gonna be easier. So in the main.ts file, if you take a look at my article and just scroll a little bit down, you will see that there is a part right after the alert, just a little bit down. So I can explain it to you. Yes, a little bit more and a little bit more. You'll see that, yeah, this is the part. This is the part. You have to put your JavaScript function into the global space namespace in JavaScript in order for WASM bin can pick it up in a simple way. There are ways to encapsulate your functions and then group them. We're just focusing on a simple single use case right now, so we're gonna put it in the window global namespace. Just copy and paste. Let's put it in the main.ts.
Doesn't
Just to
matter
keep
where,
things simple. Yes.
so I can put it at the end, right?
Yes, you can get rid of greet because yes, it reloaded. That's why you see the Chrome. Just get rid of greet for now because we don't need it. Because it's gonna keep opening the alerts, which is really annoying. So
Yeah.
we have our GS function. It says hello from GS. Let's call it from Rust. You just simply add the GS function to the extern C block. If you need a little bit of help, it's in the article next segment. But
So
it just add you
here I
just
have
yeah
to add
you
the unsafe
fn
is just fn, and then it's
simply
for
fn and exec
JS function.
naming GS capital F function. Yep, and it already loaded and it recognized that is a function in
I
our
wonder
JavaScript.
if it's Visual Studio Code doing it or the Copilot that I have. That it just okay.
Wasn't
It
been then
already read
generates
your
the
article and now it's copying from there.
probably. So it already set up. Type check actually works. You can see that it already sees that there is a JavaScript function present which you try to call into, and then all you need to do is just comment out the alert in greet and just call a GS function. Yes, and
Which would
what you
do
need.
another.
Hmm?
Okay. Sorry.
So all you need to do, just call the greet function after your function definition in the main TS file. Just call greet. You're gonna call into
Here?
You're gonna call into Rust. Yes, greet, because we already imported it. Yep, that's it. Hello from
Okay.
GS. So what happened here is that we called the greet function in WebAssembly, which called into JavaScript with the JS function, which called alert showing the little message
Okay.
that we
This
set
great.
up.
Okay.
So now we can see how you can define functions in JavaScript, call them from Rust, how you can define functions in Rust, call them from JavaScript.
Mm.
Could be another Git commit moment if you want to
Right.
record the history.
Right. I'm still trying to understand what just happened. But yeah.
Let's
Okay.
talk about it then. So basically what happens here is WASM bin magic. This is the binding generator for you working in action or doing all the action here. There are a lot of nuanced things going on, how you map things, especially things like strings between JavaScript and WebAssembly. It is all papered and covered for you by WASM bingen, and these WASM bingen macros you see added to the extern block, the function, and probably not today, but you can actually add it to practically anything in Rust, and it will most likely have a good default and expose it to JavaScript for you. So it's quite flexible. As somebody mentioned, it's quite mature. Gregory, thank you. It's quite mature. I used it in production projects and it works really great. And as you can see, relatively easy and fast to develop with. Okay. Any questions? Let's just have a moment and see if anybody has any questions, because this is the very basics of how you can integrate these two technologies
Okay.
together.
Let me try to go over what there is actually something I think, or did you read this already? Maybe it's
Which
coming
one?
to.
Sorry.
I think this is the future of web. I
Yes.
have built an SDK on Rust WASM 32 with WASM by Bingen for blockchain. I'm currently writing a white widget loader loaded in Angular, loading WASM exactly like your example. If you want to see it live, let me know. I share my screen. Maybe later. Okay.
Yes, sure.
I'll try to go over what we just wrote.
Okay.
So because I'm not. So this basically this is what you this is how you define a function called GS function and put it in the global namespace, right? Of the
Yes.
window on the window. Okay.
Yes.
Why do you need this whole thing? Why not just call it JS
So
function?
you
Why
don't
do you need
have
this window
to.
here?
Yeah, so you don't have to do this. You can actually package it up. Later, we will see that it can be packaged. You can even call into class instances. Basically, whatever you can imagine can be done. WASM bingen can take care of it. Right now, this example tries to be simple. It's
Yeah.
an easy way to show you how the basic global namespace function can be called from Rust.
So
Unfortunately,
basically,
go ahead.
no, I'm trying to still. So this is how I define the function. This one is needed because why do we
Yeah,
need?
so yes, that's what I tried to. Yeah, that's where I was at the moment. Yeah,
Okay.
so the reason why you have to put it explicitly in window is that how the ESM, like the what's it called? So basically, how the packager packages your code into JavaScript modules, they are never global namespace. It's just a quirk of how the ESM module bundling and module handling in browsers and JavaScript engines work. Because we are using TypeScript and it is configured the way it is configured, whatever function you define here in this file, it will not be a global function. You will not be able to access it from your browser console. You can try it. You can define a function here and you will never be able to call it from your console unless you know what you're doing, but let's not go there.
Okay.
It's not global. So what I do here is that I will say explicitly that it has to go on the window of global object. That's the only way Rust can access this function reference so you can call into. Otherwise, it doesn't know how to call your function. Does that make sense?
Right, yeah, I think so. Yeah.
So it's just a nasty but simple example how simple function calls can work between the two platforms.
Mhm.
Do you have other questions regarding
No, I
this?
think it's okay. So in the other side, I just have to put in the same signature that we have here,
Yes.
and then I can call it from here. Now I have to pass. And earlier we passed in a string, so we know how to do that already.
Yeah. You can actually add a string to greet in Rust if you want to, string slice specifically, but string will work as well, or an own string, and just provide the parameter in TypeScript, and it will get it in Rust, and you can print that out. Why don't we
Mhm.
do it right now? Just simply add the string size
Okay,
parameter to greet.
so we would like now the greet function will basically I would like to get here foo right?
Sure, sure. Yeah, it keeps alerting, but let's disable it.
Okay.
Yeah, okay.
So for now it's
So
not
yeah,
this
so we're
one.
gonna change
Now
that.
for that I need to, so the greet is just a function here. So I do I need
In
to
Rust.
I don't need to I don't I mean I import just a name here, so I don't need to put
Yes,
anything
yes,
else.
yes, yes.
And here I need to tell it that it accepts um, it's just
String slice.
Rust here,
Perfect.
right? And then
Perfect.
this would, let's say, call alert with the S,
Why not?
right? And now
Sure,
if I enable this, then it will say, and we don't see well, but it says foobar, right?
sure. Yeah, that's
Okay,
that easy.
nice. So
Mind
I can
you,
write
if
anything like a math or something, any stuff, and I
yeah,
can
but
just implement it.
you have to limit yourself in this regard. You have to limit yourself to simple JavaScript types, uh,
Mhm.
with some exceptions. But we will see how we can add complex, or how we can pass complex parameters between Rust and JavaScript in a moment. But before we do that, I don't know about you guys, but I'm quite annoyed by these alert pop-ups. Why don't we use a basically console log to log into the console from Rust? So if you go back to my little article, um, you will see a section called using existing JavaScript APIs and functions. If you go a little bit further down, yes, this is it. So let's add this dependency, and we need to add it manually because I mentioned this before. This is the WebSys package. I just add it to Cargo Tomo. The reason why we're doing it, I mean, we could add it with cargo add and specify the features. It's just
Sorry, will we add it just as it is?
a dependency in cargo tomo. The reason
Okay.
why it's like this is to show you guys that it actually adds a specific feature called window, which we will need. And the other one which we will need, which is not present in the article, and that's a problem. Hold on. You need to add console, I believe, to the feature list because window is not enough.
Like, how do you do this? Yeah, I think so.
Just
Console. This,
yes, I believe, but it
that,
may be. Hold on, let me check. I think it has to be capital letter console. No, no, you're right. No, no, Oh, good. Just simple console, not capital letter console. Okay. So once we have this and we install the packages, hopefully, or it will automatically get downloaded once we build the Rust code again. We will have access to the WebSys,
Basically, if I just make some changes, it will do it, right?
hopefully, yes. It should. You will see in the console the cargo build command, but White probably.
So I will go to
Sorry, terminal. I meant terminal. Sorry, terminal.
in the in
In
our terminal in this one.
VS Code, yes. And if it built it, you will see it. Just White actually scrolled it out in your terminal. Whether or not it added the package, that's what basically was what I'm looking for. A
I
little
didn't
bit
say
more. Ooh, I don't know. Anyway, we will see it very soon. If it doesn't work, VS Code and Rust Analyzer will let us know.
Okay.
So then we will fix it. I promise.
Ah,
So
annoying.
what
Yeah,
happens now
no,
is
it was
that
just
if you
annoying.
it will all work out, I promise. So if you go back to my article, you'll see that how exactly you will be able to call WebSys console.
This.
It's basically console log. No, you don't have to copy it. It's just the one line, WebSys console. It's the WebSys package. It contains, now that
Oh,
we
this
added
one.
the
I put it
feature.
in the FN
Yes. Yes. It's
in
basically,
here.
yeah, basically the only thing we need, and let's just quickly review it. Only thing that needs to be probably imported if the WebSys package is available. Yes, now it is compiling WebSys. So yay! Okay, we have it. So
it
it's
failed.
easy to failed. Yeah, because we have an error. It's not one
Because it's
on one.
person and not S. Right. Okay.
Yes, yes, yes. There you go. It worked. Perfect. So it's super easy to call console log in JavaScript, and you just dump multiple parameters, um, into the calling signature. That's not so easy with compiled languages like Rust. Not compiled, sorry. So lower level languages like Rust. So it basically what it does is it has log1, log2, representing how many parameters you would like to add to the console log. So we use log1 because we always log a single parameter, which is a string. You can actually have called console log, which receives an array of parameters and it logs that, just pointing it out that there are variations and not that complicated. It's easy to figure out, but right now we're going to use this particular single parameter console log call. As you can see, if we rebuild and open Chrome, you will not see the alert anymore, which is super annoying, but you will see it in your web console, the message we sent.
So let's add buzz as well, and then
Sure.
here we should supposed to here. Yeah.
All right. You can also use console error, console warn, just like you would from JavaScript, the same way. Okay, so why don't we pass more complex parameters around if you're ready and if you don't have any questions.
Yeah. I just go. Okay.
going forward, I would recommend copy pasting from the article just because it's a lot of typing otherwise, and we will be sitting here until the
Do you
morning.
notice the discussion in the chat, by the way?
No, I'm checking it right now. Yes, Gregory, it's correct. You can use, by the way, WASM code in web workers, but by default it runs on the main thread. But you can use web workers with WASM. Today we're not going to cover it. It's not that trivial, but it works great. So yes, this is the type of scoping with the JS namespace parameter to the WASM Bingen macro. What I was talking about. That's how you can group stuff and still access it from Rust easily, just like with the console namespace, which you can think of as an object in JavaScript, and basically you can prefix it and use it simpler, just like Gregory shows. Okay. So why don't we pass a class reference, class instance to Rust? I wrote a little class in TypeScript, the tsdef, just named it tsdef. Just put it in the main.ts file. Yeah. So that's a simple class as a constructor with a string parameter and string attribute rather. And it has a message, does a console log, prints the ID. Absolutely the simplest thing you can do. Why don't we basically map it to the Rust code and see how exactly it works. Just copy and paste this section into the Rust code so we can talk about what's going on, because it's a more complicated setup than the previous ones. So we still have a function, remote instance param. I named it remote instance param the same way as greet, but it receives something else. If you scroll a little bit down in lib.rs. So it receives the pointer to a tsdef struct. So JavaScript classes become mapped to structs in Rust, and then you can call the functions, access the parameters just like you would in JavaScript. How exactly that mapping works? If you scroll a little bit up, we will see how a struct is mapped basically. A class is mapped basically to a struct in Rust. A little bit further up, please. It's still an extern block. Again, there are more idiomatic ways to do this. This is a simple example to show us how exactly it works. It's an extern block with a WASM bindgen macro. You have to define a type, which actually name matches with the JavaScript side or TypeScript side. And then you have to define basically all the functions, which are like you can see the example at the bottom, the run method, not a function, sorry, a method on your class in JavaScript, which receives this parameter. It's not the same as self, because there is no self. This is not a sort of traditional struct in this sense. And then you can see some magic with how you can access the public attribute on the class instance, which is called ID in our case. What it does basically is that it takes advantage of the JavaScript object prototype method getters and setters, and it does that by defining this specific nomenclature. So the attribute is called ID on the JavaScript side. So we call it ID in this extern-C definition, basically mapping it with the WASM bindgen, macro. You have to provide these parameters so it knows it actually needs to generate the getter mapping for you. And almost similar, the setter part, which is called the object prototype chain setter for the parameter. Again, naming is important, and you add the WASM bindgen macro with the setter attribute to
This one.
create the mapping. Yes.
Right. So
Again,
this is how we define the getter to be ID
yes.
and the setter. But you say that the name is also important. That we
It
could
is
set
really,
something.
really important unless you parameterize the WASM bindgen macro to use, a manual mapping. So it's just to not confuse everybody, I chose to follow the naming convention and
Right.
just a simple WASM bindgen macro call, but you
So,
can configure pretty much everything with WASM bindgen. You can add your own mapping, JS name, you already
there's something naming, right?
JS name. It's always JS underscore something with WASM bindgen. Yeah, so you can add it. You can add your own.
Okay.
Let's just focus on the simple example for
Yeah.
now,
Okay.
and people, as an exercise, can try to do these additional configurations. And what happens here is that the function which we're going to call from JavaScript, the remote instance param, receives that type definition, which is auto-generated by WASM bindgen for us. And look, it just simply calls the ID function just like you would in JavaScript,
Here.
and WASM bindgen takes care of everything for you. So why don't we try to call this remote instance param on the JavaScript side and see what's going to happen?
Mm. I don't know. I tried to copy.
Yeah, copy paste it. Fine.
That's what I tried, but it didn't like me.
You already have it. Just enter. Yep.
Okay.
Why not? There you
Yeah,
go.
there it
And
is.
then, yes, and then just press OK.
Yeah, so
And
I
it
can comment
already,
out the previous one.
yeah, yeah, it's
Sorry.
probably not useful, but the alert is in the new function, so that's why you're getting
Yeah,
these
so I can
pop-ups.
comment out also that alert.
You can actually use the console now that you
Yeah,
know how to use it. It's easy to modify it, just copy and paste if you want to avoid the alert.
wait a second. I can copy this console, right?
Yeah, probably easier to follow than with the alert.
So I can, I don't need the stringification here. Right. And now it says here that that's ZYXW.
Yes, because it was
That's
overridden in Rust, so it sets the ID ZYX ZYXW. The question is, why don't we call into the console log in Rust? Maybe you need to reload. Maybe your console
no,
contains
no,
an
no.
error.
I
I
see.
don't know.
Isn't the thing that this one that's a pointer and then the browser replaces it?
Probably could be. It worked for me. Maybe it overrides it sooner than sooner than it actually displays.
So yeah, you see? Now it
Yeah.
says ID 123, and when I let the alert go through, then it replaces it.
Yep.
This is I mean, yeah, because it's a
Can you
pointer there.
can you scroll up in your console? Maybe you don't need the alert. We just haven't seen the message. Because see,
Do you think
so
so?
maybe you don't
Maybe.
maybe you don't need the alert to wait for the process, because I don't think you would need to, because it runs on the main thread. There are no parallelization.
So I clean this up.
But
I remove the alert, and yeah, you're
there
right.
you go. I would have been surprised, honestly. But
Yeah,
okay,
but I
cool.
saw this. I mean, maybe it's with objects that it's replacing the data inside.
Cool. Yeah. Usually a reasonable guess in this case. This runs on a single thread, I would say, a main thread. So
Okay.
it should be sequential. Okay. So again, let's get back to our VS Code and let's stop for a moment. Do you have any questions? Do anybody has any questions? What's going on? It's a little bit more complicated of an example now, but
Anyone,
we can
people,
see.
questions? Okay, people, ask questions while I
You
commit
can,
the code.
yeah, you can see how basically passing complex types and complex data via pointers and mapping them in Rust would work. It works the same way when you do want to share a Rust structure with JavaScript. I believe in the article you'll find another example later down the road, a little bit down the road. I actually create a person struct. I don't know if you want to spend time on doing this because there is a little bit of a gem I wanted to share with you, and it's also in the article. So maybe we don't have time to do this, but you can check it out. It's very similar. It defines struct. It implements the binding via WASM bindgen, just sets the markers. And then if you scroll a little bit further down, you will see that you can just simply import the person struct as a class from your WASM package, and you just instantiate it, and you can make changes
Right.
just
So
as you
so
would
this
with
is the
the,
opposite way, right? When you have a struct
yes,
in Rust and you would like to provide it to be accessible from the JavaScript.
yes.
Nice.
One thing I would like to point out, since we talked about pointers, you don't get the luxury of just leaving your instantiated structs from WebAssembly around in JavaScript. You have to explicitly call free on them, which is a method added by WASM bindgen, because Rust doesn't have, oh, sorry, WebAssembly doesn't have garbage collection. You have to be responsible for cleaning it up. There is no drop semantics either, because it's the reference is held by the JavaScript engine. So Rust never knows when exactly it is released. This is how you
Mhm.
get this is how you let the Rust code know that you no longer need it in JavaScript. It can be freed, and then drop is called. Everything's taken care of. So that's the
Interesting.
only quirk you need to be aware of when you actually instantiate structs and store data in Rust memory or WASM memory and use it in JavaScript. So this is the
Mhm.
gem, finally, I wanted to show you guys, because you can actually do debugging just like you would with C or Rust in Chrome. This is a Chrome only feature. You have to install this extension I link here because of
This one.
how, yes, because
Yeah, you already
WebAssembly
sent
is,
me, right? And then I installed it.
yes,
Yeah.
hopefully
Okay.
you already installed it, yes. So
Can we check?
let's
Can
just
we
quickly
check it?
set it. Yes, yes, let's do it.
Okay, whatever, bro.
Top right in the puzzle piece, you should see your extensions, the puzzle piece icon, top right. There you go.
This one, it's. Can you see it? I don't see it. Okay, this one. Yeah, it says it's in there. Now you
Okay,
can see.
yep.
I mean,
So there
for
is
me, it's so
one,
small.
I don't know how you can zoom in, unfortunately.
No,
Uh,
this is my internal screen, and the resolution is. Maybe I should have changed the resolution, but I don't want to touch it now.
Live and learn. Anyway, you need to do one other modification because it's a security risk, and you need to make the change manually in your preferences in the DevTools preferences in the cog icon bottom left ish. No, it's in the DevTools where your console browser console is
Okay,
to the right, all the way to the right, all
security.
the way. No,
No.
no, the cog icon. And then it's already in the preferences, and you have to scroll a little bit down in this pane, and you will see a section called Allow DevTools to load resources. It should be there. There you go. It's at
Yeah.
the bottom. Yes, you have to click that because otherwise it will not load your source files properly when you actually halt at the breakpoint. So that's an extra step you need to do. I don't know, sometimes they change this with Chrome releases. Right now, this is the magic switch which solves the problem. The other thing which we would need is add the Rust source code. I don't know if you already added your Rust source code to your system. You can find the command in my article. It's Rust app component add Rust source. So let's get back to your
This
There you
one?
go. Yep. Let's add the source component if it's not there yet, because if you step into in a stack trace, you step into the Rust library, you won't have source view, which is unfortunate. Oh, there you go. You already had it. And then here's the other part of the debugging magic in the article. You have to add this part, this metadata change to your cargo toml. What it does is it tells WASM back, our favorite builder, to do not throw out the dwarf debugging information, because it does throw out the dwarf debugging information, which we will need in the browser in order to resolve function pointers and variable names. And if everything went well and everything rebuilds, you should see in your console that the library already picks up the dwarf
This
debug
console or the other
information.
console?
This one, sorry. I'm gonna call it
Yeah.
terminal. This
We have
one's
too many
terminal.
consoles.
Yeah, this one, that's probably because I'm Hungarian and that's how you used it here. So if it rebuilds in the terminal, you should see it in your console that the extension, the Chrome extension, picked up the debug information. Can you see if you reload in Chrome? Can you see that it picked up?
How can I see it?
It should be in your console, but I see it's
In this
not
one?
present. Yep, it should be there.
Why it's not?
Um,
Nothing.
can you please open up the little puzzle piece and see if the extension is enabled? Because it might not be enabled. Yeah,
Let me move it to the other screen. It I, so this I think
it
it's
is
enabled.
enabled. It should be enabled. Then what could be? Maybe we should delete. Just exit the white from terminal.
Wait a
The
second.
white
I just
process.
forced it to recompile everything.
Yes,
Right?
because I suspect that it's still not putting in the dwarf information. So just cancel it in your terminal. Remove the pkg
You mean
directory.
this one?
Yep, remove the pkg directory just to be absolutely 100% sure it's not gonna reuse the old compilation.
That's
Yep. And then just restart, and it has to recompile everything now. And let's see if it loads this time.
okay.
There you go. So now the debug information is read by the extension and it is available in your console. So now if we open up sources, the sources tab in the console, the DevTools, yes. And just give us a little bit of space. And on the left panel, just extend the left panel a little bit so we can see. There is something new. We didn't check it before, but there is something new which you wouldn't see without the extension. It's the file section at the bottom. You can open it up. Yes. It should contain your home directory already and a couple of other things. Just open up your home directory. It's home Gabor.
Will I see all the
And there you go, work, WASM and web source. So it's not all your files, it's just what the WASM compilation contains. Just open up work, WASM and web source. And we will see that we have lib.rs in it. Just open it up, and we see the source code. Perfect. Maybe just leave a breakpoint somewhere just to see if it works, wherever it's reasonable in that file.
This is how I put a break. I never use this.
Oh, never mind then. That's it. Perfect. And just reload. Reload the browser page. And don't close this window, of course. And there you go. We are at a breakpoint. It actually stopped, as you can see. And on the right side, you can see the parameters.
If I go to the terminal, if I could go to the terminal, it's console now, sorry. So it didn't print out those two messages yet.
No, it's actually holding on the breakpoint, exactly.
Yeah.
And you
So
can
if I
see the parameters on the right side.
Oh, okay, nice. And I can
So-
have the steps here. So I can step.
Yes, you can.
That's step 1. No, that's step in. So that's step out.
Yes.
Oh, I can
Yes.
step.
Yes,
Okay.
here's the little caveat part. It's great if you don't have other tools to debug your complex interaction with the TypeScript and JavaScript and WASM, but it has its limitations. It usually leads you to memory addresses, which are not very useful unless you do know what you're doing and you can inspect the JavaScript memory and gather what exactly WebAssembly stores at a given memory address. But in general, I found it easy to just have a quick step through in your code when you don't know what's going on, which was previously, I mean, a couple of years ago, it was super hard. Now it's actually super easy. As you can see, you can set it up for yourself and then, step through the code, see what's going on. And you can actually do the hybrid step through. So whenever the JavaScript part steps into the Rust code, you can follow it along. But understand that you are using WASM BinGen. It generates a lot of code in the background, which you won't see unless you do debugging. In which case, you will see every nitty-gritty details, what exactly generated, in order to make sure that the interaction between JavaScript and WASM Rust works seamlessly, like we experienced today. So the reason I wanted you to add the Rust source code, and we haven't run into that yet, is that you can actually map it up to the DevTools console and have the Chrome DevTools open up your Rust library sources if you want to. I don't know if you want to do it. It's not that complicated. What you need to do is you need to somehow copy, I don't know if you can copy the part in the file on the left side of the sources panel. Under file, you will see something like to the left, yes, at the bottom. You will see, yep, something like, oh, you already stepped into it. That's great. To the bottom, go to the bottom. Yes, yes. So you will see that it says Rust C /9OB35A. It's a hash. See?
This one.
Can you copy that directory name?
How can I copy it?
Unfortunate.
Wait a second. I'll take a look at in the other window. No, it doesn't have a copy there.
Don't worry. I hope that we can actually do it live, but maybe I just quickly show it to you guys and then we wrap it up. Why I wanted you to copy and paste it, if you bring it back, there is a neat trick with the Chrome extension. Just open up the,
Wait a second.
finish.
I don't have this in the other terminal? The same
No,
thing?
unfortunately, this is an artifact in Dwarf. It uses this masked directory or virtual directory for the file references. But let me tell you what, and it's actually detailed in my article. Let me tell you what I would do with it. So you can actually map it to your Rust source code. If we were able to copy and paste that name, if you finish up the debug session, because it's going to cause some problems for us, just let it run and remove the
This one?
yep, let it run and remove the breakpoints. Yes, just go for it. Okay, so if you open up your puzzle piece, your extensions, you will see that there is a 3-dot menu.
Wait a second.
Top
Here,
right.
this one?
No, top right, the puzzle piece, the extension manager.
Okay.
Yes, 3 dots, options. There you go. Can you zoom in a little bit so we can see?
Yeah, this one
So
at least I can knock it out.
you can actually add path substitutions. So these virtual directories, like the Rust C/the hash code, can be replaced with your absolute path to your Rust source. And what the little extension will do is going to access your local file system and load the Rust source code files too. So actually you would be able to have full source code all the way down to the bottom of the stack. It's just a neat trick you would enjoy if you actually want to step through the code. The other probably more useful effect adding these Rust source codes could be is that if we were to generate an exception or a panic, it would actually, on your console, it would actually display the stack with the proper file names and paths and line numbers, which is very useful debugging and collecting information on crashes, because that happens even with Rust. Okay, so
Shall
I
I
would
put
say
just a panic in there?
we can try. I don't know if it actually will resolve everything now that you don't have the source code mapping in there.
Okay,
And there is
then
another.
yeah. Go ahead.
Let's put in a panic. Let's see if it logs it properly. At least it should show the lib.rs file, the first line in the stack.
I
It's
can
stack
say here
trace.
panic. Boo. Okay.
Let's see.
And I don't know if it should do something here.
You would see it in your console, if anywhere.
This console, yeah.
Yes.
Okay.
So this is the stack trace from your panic. And as you can see, why is it upside down? Anyway, the last one is the remote instance parent function from the JavaScript hoisting. Previous to that is the hoisting from the Rust side. And then the third to last is our function in the lib.rs lib.rs file in the 38th line, which is exactly where the panic is, I'm guessing. And you can see some of the other stack trees.
This one.
Never mind, it's the fourth one. Sorry, yes. Kind of mixed up a little bit, yes.
Yeah, okay.
So that's why it's useful to have this set up, and that's why it's useful to have this little extension. It would make your panics clearer, basically, what happened, where exactly you need to look. Yes, it contains some of the artifacts from WASM BinGen, but I think it's arguably better that you have this information at your fingertips.
Yeah, indeed.
So, as a final step, and we won't do it in ourselves in code, just want to point it out in the article because we actually spent a lot of time with this, is that indeed there is a way to run it outside of the browser. And in order to call system calls, just like you would with C or Rust directly, there is an API called WASI, or WebAssembly System Interface, which tries to re-implement all the usual stuff you would get on, say, Node.js or Rust. So file handlers, network access, anything else basically that we would need to have a full-fledged platform and run it on, say, the server. Somebody mentioned, maybe it was Gregory, I'm not sure, that people starting to pick it up and it's starting to gain traction in Web3 crypto spaces because it's ability or capability to run in a platform independent manner. But I also enjoy seeing it picked up by sort of like the new generation of JavaScript bundlers, like SWC built by Vercel, as a plugin interface. So basically, anybody can create plugins in any language, compile it to WASM with WASI, and these bundlers can load it no matter which platform they run in. And I'm sure there are tons of other use cases, and people are starting to experiment with it. In the end of the article, I provided a somewhat older repository which uses an old version of SWC just to transpile a sample JavaScript file from the standard input. It's basically does what it says. The specialty is that it can actually open standard input and standard output and use it, which wouldn't be possible without the WASI interface. Okay, I think that's it for my end. If you have any final questions on any of the things we talked about, then I'm happy to answer them.
I'm exhausted. Thank you.
I can imagine.
Anyone, any questions before we stop the video? Yes, there is. Wasn't Banjan returning back an unreachable panic is very common in the console. Really hard to understand. So this debug wave could be really useful. Thanks for the
You're
tip.
welcome.
I think you were evoking Xtism. That is a framework
Yes.
to build WASI.
There are a lot of frameworks which make it easy. I try to create a very basic example just for a tutorial presentation and article, hopefully, and self-contained one. Hopefully that would make it easy for you guys to get started, to try it out, and then you can branch out and learn more. And that's actually a great segue to the last paragraph, and I added to the article as well, where to go from here. And these are two open source available books. The Rust WebAssembly book, which is a great starter. This presentation is heavily relied on that book. And also the WASM Binjan guide, which gives you an insight into how WASM Binjan works and gives you lots of examples and techniques to do practically anything with WASM Binjan. If you actually process and grok these two books, you would be well versed to do practically anything with WebAssembly on the web in the browser. WASI is somewhat different. There are various materials. Again, it's very early still. It works, but it's most of the time it's unstable. I actually mentioned that Node is already sort of WASI compatible, although it's in an experimental mode. Node 23 can now load WASI preview 1 binaries and run them. Sort of a good spirit, with sort of a good success rate, I would say.
There's another comment. There seem to be so many moving parts, any of which can cause a problem. What is the simplest, smallest combination of tools to enable Rust to augment HTML5?
I would say this post wanted to do, and this presentation wanted to do exactly that. I would say the first half, when we hooked up Vite, the plugins, and WASM Binjan is the simplest case of all today if you want to use this technology stack. Again, I understand that it's overwhelming. It's not a simplest topic on itself, but I guarantee if you get started tomorrow and just follow the article, or the post, it would make more sense. Especially that now that we have a recording, it's easy to
Yeah.
just go back, stop it, and maybe get some more context from my article, or just open up the Rust WebAssembly book or the WASM BindGen book and just figuring out what's going on. But once it clicks, just like with the borrow checker, I would say, once it clicks, it just makes sense.
Yeah. Yes. It just takes a long time to click. Yeah, I guess.
This
But
one, I hope it's easier.
yeah. No, it seemed. I mean, now that it's working together, it seems easy to copy paste something and tweak a little bit and then start adding more
Hopefully,
functions. So
yeah.
this is what I'm missing from a lot of pieces of code, even in Rust, but in many places that I mean, we don't read that much of the documentation usually. Only when everything else fails, we usually copy paste and then start to tweak and want something to work. I mean, at least but I think many other people do that. So the fact that we have something working, the whole cycle here, that's I think it's great. So this is how from this point it's way easier to do all kind of other things.
So I hope so. That's the goal.
Yeah. So thank you very much. If yeah, the presentation was awesome and huge work of preparation. I am using this technology for 2 years, and I believe this is the future. For me, it's production, improved every day. Indeed, the first thing to really understand the power of this Duo is to log and play between and WASM. Then with structs, you can put 90% of the code in Rust, and TS is just using the library. Indeed, interesting, and thank you very much, Mark. It was absolutely. I don't know. I would like to use some very high word in English, but I don't know anymore anything. So I just want to thank you, and
Thank you for having me.
yeah. And thank you everyone who was watching to this point, and please like the video and follow the channel. And I will put under the video some links so you can, I mean, you'll have the article and how to find Mark. So that's it, right?
I
Thank
think
you.
so. Yeah, it was a great time having you guys. Thanks for the questions. Thanks for coming with us on this Rust and WebAssembly journey. And I hope to see many, many great WebAssembly solutions. Let us
Yeah.
know.
Okay, great. Thank you very much. And
Thank you.
hopefully see you soon. Bye-bye.
See you. Bye-bye.